So I either have to record 5th or 7th. And one day when I recorded 7th, I was here till almost 5:45 waiting for it to upload correctly. And I decided I wasn't doing that again. So y'all are the winners. Okay. So when this says use the binomial theorem, that is using the coefficients that we found from Pascal's triangle to expand this binomial. Okay, and which problem was it that someone asked about? Was it number 10? We talked about number 10 just a second ago. You could either distribute this first and then take that result and distribute that result through the second one, or you could multiply these two first and then distribute the x cubed through. Either way for number 10. Somebody over there asked me about one of the problems. Which one was it? I can't remember. Nope. Okay. Must be good. All right. So for those of you that are watching this at home, we did another practice problem of expanding using the binomial theorem, the coefficients that we found from Pascal's triangle. And we might do one of those again tomorrow. Now, those of you that are looking at your calendar, you've noticed that there's not a quiz scheduled for this week. But Thursday, there is a graded in-class activity. It's a campground task. So tomorrow, we're going to play a review game. And then tomorrow night's homework is actually on the back of today's notes/homework. So you'll have both of those. So if you're absent today, make sure you ask for these tomorrow. Today, we're going to look at the last operation. We've done addition, we've done subtraction, we've done multiplication. Now we're going to do division. So we're doing division of polynomials. And we're going to look at two methods. We're going to look at long division and synthetic division. You're going to like synthetic the best, but it doesn't always work. So the first thing we're going to look at is long division, because long division will always work. Now, we're going to use long division in here when our divisor is not a linear binomial with a leading coefficient that is not 1. So if we had a divisor that was a linear binomial with a leading coefficient of 1, we probably wouldn't choose long division, we'd choose synthetic. All right. But to prove a point later on, my first long division example actually is with a linear binomial divisor with a leading coefficient of 1, isn't it? So after today, when we do this, we probably wouldn't do this problem as long division. But let's take a look at this. First of all, let's remember division. Remember long division? Here we go. So if you had something like this, 42 goes into 976. How many times? And you didn't have a calculator. This is what you did when you were in elementary school. You said, okay, 4 goes into 9. How many times? 2. Not 3. And so the 2 goes there. And then you said, okay, 2 times 42 is 84. Do you remember that?
No, I don't.
Yes.
And then you subtracted, didn't you? Okay? And so that left us with 13. And then did you bring this down? Okay. And then you said 4 goes into 13. How many times?
3.
3. And then you multiplied, and you got... And then what did you do? You subtracted, and you got 10. And what was 10? It was the remainder. Now, when you first started doing this, you just wrote R10, didn't you? Okay? And then later on, we started writing 10 over the 42. We wrote it as a fraction, didn't we? Okay? That is long division. That's what we're going to do today. But we're going to do it with polynomials.
Oh, right.
Okay, so when we set up long division, the divisor, that's the name of the thing we divide by, goes out here. The dividend goes under. Dividend is what we divide into. And what do we call the answer to a division problem? Quotient. Good. Okay, so just like we did over here with plain old numbers, we do the same process. We're going to take this first term and this first term. And we could say x divides into 2x squared. Well, guys, doesn't x squared just mean x times x? So when I divide, doesn't one of those x's cancel and it just leaves me with 2x? Okay? So with division, we can just do that canceling. This x cancels with one of those. Okay. Now, some of you are backwards thinkers. Let me explain what I mean by that. Like whenever I was given a problem like this in elementary school, I never subtracted. I always just added backwards. What do I add to 19? Well, if I add 1, that gets me to 20. And if I add 20, that gets me to 40. So I never actually subtracted. I just added backwards. Some of you are going to be like that now. You're going to go, okay, what do I multiply x by to get 2x squared? Well, obviously I got to multiply by 2. And here I only have 1x, but here I have 2, so I need a 2 and an x. You can think of it either way. Now, do you notice how I lined up this linear term over a linear? First degree over a first degree? It's not critical that you do that, but it's nice if everything lines up, because then you know when you're done. Okay, I'm going to erase this part right here to give me a little extra room to write. So now we take this. Remember over here, we did 2 times the 42, and it went right here. What do you think I'm going to do with this 2x? I'm going to multiply it times x plus 6. So 2x times x is 2x squared. 2x times positive 6 is plus 12x. Now, over here, at this point, I subtracted. I've got to do the same thing over here. But when I subtract, it's going to change all of the signs. I have to distribute that negative. It's subtraction of this entire polynomial. So my goal was for that to cancel, did it? Okay. And then I get 7x plus a negative 12x. What is the result? 5x.
Wait, I'm so confused. Why'd you put the signs?
Because when we do long division, we did 2 times the 42 is 84, and then we always subtract. So we do the same thing with this long division. You always subtract. Yes, Alice?
Negative.
Yeah.
That is correct.
I was about to say, I'm like, question.
All right. Now, with this negative 30, we're going to drop it down. What do I multiply x by to get negative 5x? Negative 5. And now we take this negative 5 and multiply it through here. So we get negative 5 times x is negative 5x. And negative 5 times positive 6 is negative 30. Now, this is nice because when I go to subtract, it's just going to change those signs. And this time, everything canceled. We get a remainder of 0. There's no remainder. So the quotient, the answer, is 2x minus 5. Yes, ma'am.
Why do you change the sign? I know you said that, but
Okay, if we had x plus 4 minus x minus 3, what do we do with subtraction? Okay, we change the sign.
sorry, that was common sense.
It's okay. All right, guys, let's keep going. Number 2. Now, this problem I would actually use long division on. The first one, I'm going to show you synthetic in just a moment. and you're going to love it, and it's going to be super cool. When we get the same answer, it's going to look like math magic. Yes, it will.
You said mathematics and you just mispronounced it, but you said math magic.
I did.
Because I can do that.
All right, so this is number 2. Okay, so we're going to put the dividend under the divisor out here. And we're all good setting it up, right?
Sure. Okay, question.
Okay. All right, so we're going to look at this and this. What do I multiply 3x by to get 6x squared? 2x. Or you could ask yourself, 6x squared divided by 3x is what? Same question, different wording. Okay, so I got a 2x. So now this 2x has to be multiplied through my divisor. 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. Oh, that's not supposed to be negative 5. That's supposed to be positive 5. Whoopsie! That's supposed to be positive 5. So that would be positive 10. That was positive 5. That was positive 5. I copied the problem down wrong.
It's okay, Miss.
I'm having a Monday on a Tuesday.
Wait. Oh, I actually thought that it was Monday.
Turtle Tuesday.
No.
It's not bad as going for me.
Little turtle Tuesday.
Alright, so now I have to subtract. And when I subtract, it changes the signs. Let's see if I can. There we go. So we're going to change these signs. So this first term is going to cancel. And this is going to leave me with negative 12x. And then I'm going to bring down the negative 5. Okay, so now we're looking at the 3x and the negative 12x. What do I multiply 3x by so that I have negative 12x? Negative 4. Negative 4 times 3x is negative 12x. Negative 4 times 5 is negative 20. And then I'm going to subtract, and this subtraction is going to change my signs. And so this time, I am left with something. That is my remainder. Okay, so my answer this time is going to be the 2x minus 4. And then the remainder gets written over the divisor. Just like it did when we did division of 2 and 3 digit numbers.
If it was negative, it's a minus.
I don't like this math.
Okay, now, Edward just said, what if this were a negative 15? If this were a negative 15, we would have, instead of plus here, we would have a minus 15 over. Okay?
I don't like this math at all.
Okay. Alright, we're going to go to number 5 next. And this is definitely another long division problem. Because my divisor is not a binomial, is it? No. So when I'm dividing by something that's not a linear binomial with a leading coefficient of 1, I must do long division. This isn't difficult though. Same exact process. Same exact process. Just a little bit longer terms. Well, expressions. I want to talk you through. Okay, so we look at the first term here and this term here. You can either say x cubed divided by x squared, or you could say, what do I multiply x squared by so that I get x cubed? Either way, your answer is x. Well, I know I'm almost done because I'm almost to the end of this already, aren't I? So even though it was long, it's not going to be long. All right, so now the x has to get multiplied through this entire trinomial. And when we multiply through by x, doesn't that just raise the degree by 1 for everything?
Yeah.
So this x squared times x is x cubed. X times x is x squared. 1 times x is just x. Okay, now I subtract. Subtract, subtract, subtract. Okay, this totally goes away. I'm left with 3x squares, positive 3x, and then I can bring down my 3. Now, because my divisor is a quadratic, we've got 3 terms here, we need to have 3 here. Okay, what do I multiply x squared by so that I have 3x squares? 3. Okay, so we get a 3x squared when we multiply, a 3x when we multiply. 3 times 1 is 3. So that when I go through and do my subtraction, change, whoops, I'm trying to do a different color. Let me try again. Change, change, change. I have a remainder of 0. So my answer is just x plus 3.
Teach us the easy way.
Okay, gotta have one more example before we do the easy way. And so we're gonna go to number 10 now. Okay, once again, definitely a candidate for long division because my divisor is not a linear binomial with leading coefficient of 1. My divisor is x squared plus 1, so it's a quadratic. I can stop there. Got to do long division.
Wait, when would you not do long division?
You
I thought
always do long division unless your divisor is a linear binomial with a leading coefficient of 1.
So it has to be like x squared plus 1. That's all I'm doing.
It would have to be like x plus 1, x minus 5. That's when we do synthetic.
Oh.
Otherwise, we do
Soda
long.
synthetic yet?
Not yet.
Okay.
Not yet. Okay, now, when we have ones like this that are missing degrees, you might find it to your advantage if you put in zeros for your degrees that are missing, especially in your dividend. Now, is this a requirement? No. Does it help students get it correct more often? Yes. Do you see that this dividend doesn't have a cubic or a quadratic? So I put in zeros for those. And the divisor didn't have a degree of 1 term, so I put in a 0 for that.
Wait,
Why did
I
you
still
wait?
don't understand what you meant.
Like, I understand.
Okay, this went from a 4th degree down to a 1st degree. It's missing the 3rd degree, and it's missing the 2nd degree. And so because it's missing those, you can put in placeholders for them. 0 x cubes, 0 x squares.
Okay.
Now, you don't have to, but it helps it line up nicely, and it helps more people get it right more often. Okay, same idea though. What do I multiply x squared by to get x to the 4th? X squared. So I'm going to line it up over where the x squared is. So if you didn't put in the 0, there would just be no place to line it up. Okay, so x squared times x squared is x to the 4th. X squared times 0 is nothing. X squared times 1 is 1x squared. Okay, now we're going to change our signs. So we change. Okay, and when we change our signs, this cancels. There's nothing really there. Anyway, it's just a placeholder. And this gives me -1. Now, do you see that this, essentially the way I wrote it, has 1, 2, 3 terms? So right now I've only got 1 term. So how many terms do I need to bring down? 2. Okay, what do I multiply x squared by to get -1x squared? -1. So -1 times x squared is -1x squared. -1 times 0 is nothing. -1 times 1 is -1. So I subtract, and when I do, these signs are going to change. And then I'm going to add. Those cancel. I'm left with a 6x plus 6. So what is this? The remainder. So my answer is x squared minus 1 plus 6x plus 6 over the divisor, x squared plus 1. That's my answer. Yes, sir?
How have you done that? You said to leave out like 0x3 and 0 plus 0.
It just wouldn't line up pretty.
But how? It's maybe different at all?
No, you'd get the exact same answer. It just wouldn't line up.
Right.
You wouldn't be able to put this over an x squared because there wouldn't be 1. It just wouldn't line up. Okay. Now let's go into synthetic division. So I've said every time for long division, we have to do this anytime our divisor is not a linear binomial with leading coefficient of 1. But what happens when we get lucky and our divisor is a linear binomial with a leading coefficient of 1? So now we're going to do that first problem again, but this time we're going to use synthetic division. Now, synthetic division is really cool, but you got to pay attention. You can't zone in and out. So if you ate too many carbs for lunch, shake it off and pay attention for a few minutes. All right. What we do when we're using synthetic division is the first thing we do is pick off all the coefficients and the constant from the dividend. The coefficients and the constants. Now, in this case, I said you could put in the zeros. With synthetic, if we're missing any terms, you must put in the zeros. It's not an option. Okay, and then we draw this little table over here. You can call it whatever you want. And what we put on this is what we could plug in here for x that would make the divisor equal 0. What could I plug in here that would make this have a value of 0? -6. All right, that goes there. Yeah, okay.
What about the x?
That's the nice thing about synthetic division. It's kind of like a shortcut, and you don't have to write all the x's. The only time we write the x's is in our answer. All right. Now, every time you're going to bring down the first one. Every time. Bring down the first one. Okay? And then the next thing you're going to do is multiply, then add, and repeat. Okay, so we bring down the first one. We multiply what's on the table times what we just brought down. Negative 6 times 2 is negative 12. So we multiplied. Now we're going to add. 7 plus negative 12 is negative 5. Repeat. Multiply. Negative 6 times negative 5 is 30. Now we're going to add 0. The last result is always your remainder. So this one has no remainder. Okay? Then we work our way backwards. This is our constant. This is our linear term. If we had some more, the next one would be the squared. If we had some more, the next one could be a cube. So the answer, when we divide 2x squared plus 7x minus 30 by x plus 6 is 2x minus 5. Is that what we got when we did long division? Yes. Yes, ma'am.
Sorry, why did you add the x factor to?
You don't do that till you get to the answer part. Let's do another one.
So can we do that for number 3?
We're going to do number 8.
Oh.
Okay.
Just by ourselves, just do it.
No. Your you tries today. Come on, your homework. All right, what goes on the table, guys? Negative 2. Okay? And then when I pull off my coefficients and my constants, what do I have here? 5, 1, negative 8. Okay, the only reason I can do this is because my divisor is a linear binomial with a leading coefficient of 1. All right, I bring down the first one. I multiply. Negative 2 times 5 is negative 10. I add. What do I get? Negative 9. I multiply. 18. I add. 10. So this is my remainder. It always goes over the divisor. This is my constant. And this is my linear term. And that's my answer.
That's so nice.
Isn't that nice? I'm with you.
Why can't they all be like this?
It's math, never pleases me.
Well, it's not really magic. We could prove why it works. It's basically just using what we understand from division.
So if it was like 5x3, we'd have to add in 0x2.
What now?
If it was like one of the numbers for that one was 5x3 instead of 5x2, we'd have to
Yeah,
add 0x2.
yeah, that's what we're doing. Last one.
Oh,
Okay,
do that.
this one is missing terms. So I'm going to have a 1, a 0, and then a 3. This one doesn't have the squared term, so a 0 went in. It doesn't have a plain old x, so a 0 went in. So whenever you're missing terms, you must put in zeros. I'm going to go a little faster this time. We bring it down. We multiply. We add. We multiply. We add. We multiply. We add. So bring it down. You multiply. You add. You multiply. You add. You multiply. You add.
It's a song.
Okay? And then we take that, becomes a remainder. This is my constant. Oops. Where is it? This is my linear. This is my quadratic term. So it's x squared plus x plus 1 plus 4 over x minus 1.
Can you simplify, let's say,
X squared plus x cubed plus 1.
No, we cannot, when we're working backwards, we cannot skip a degree.